All right, ladies and gentlemen, today we're going to be going into a new unit into our electrochemistry unit. So electrochemistry is the process of chemical reactions that produce or require electrical current. So first one we're going to be talking about in our electrochemistry unit are oxidation-reduction reactions. We usually write that as Ox-Redox reactions. So an Ox-Redox reaction is the type of reaction where electrons are transferred from one substance to another substance. So there's four terms that we need to know when we're talking about Ox-Redox reactions. Our first one is oxidation. So this is the loss of electrons by a reactant. Reduction is going to be the opposite, so it's the gain of electrons by a reactant. Our oxidizing agent is our substance that causes oxidation by being reduced. So that's the one that's being reduced that's causing oxidation. And our reducing agent, as you can probably guess, is our substance that causes reduction by being oxidized. So it's being oxidized, so it's causing reduction. All right, when we're solving these, we need to remember the term oil rig. So what's oil rig? So oil rig is an easy way to remember those last few terms there. So oxidation is losing, reduction is gaining. So we have OIL, RIG, oil rig. Oxidation is losing electrons, reduction is gaining electrons. Easy way to remember that. When we're solving these, we have 5 basic steps that we're going to be doing. So our first step in solving an Ox-Redox reaction is identifying the elements whose oxidation number is changing between reactant and product. There are 3 specific things that we're going to look for when we're doing this. So our first one is a single unbonded element. So something that doesn't have a bond. Looking for metals that are identified as do not know, so we don't know the oxidation state of those metals. We also want to look for the center atom of a polyatomic ion. So we got to remember some of those polyatomic ions. Next step that we're going to be doing is determining the number of electrons lost or gained as we move through the reaction. Next step, we're going to check to see if one element is on each side. If not, we're going to multiply by the multiple. We'll get to that in just a minute here. Then we're going to get the number of electrons lost equal to the number of electrons gained as we move through the equation. And our final step is to balance by inspection. So we have to look at the equation, make sure it's all balanced. So we're going to do this one together real quick. So we have SnCl4 plus Fe makes SnCl2 and FeCl3. So we have tin chloride and iron makes tin chloride and iron chloride, ferric chloride there. So first thing we're going to look for on our steps is the oxidation states. So we're looking for metals that are unbonded atoms. So we have iron here in the middle that's unbonded, so its oxidation state is 0. Next, we're going to look for ones that we are aware of. So we know chlorine is -1. So we know chlorine from the periodic table, its oxidation state. And then we're looking for the ones, the metals that we do not know. So we don't know tins, or irons here. So we have to figure out their oxidation states, and that's why we're looking at the chlorides there. So for the first one here, we have -1 for the chlorine times 4 of them. So we know that our tin there is going to be +4 to balance that out. We have -1 times 2 here is 2. So we get +2 for the tin over here. And then -1 times 3 is -3. So we get +3 for the iron over there. So we have to look to see what's changing now from one side to the other. So we can see that this iron goes from 0 to +3. So that is a change of 3 electrons, and we're losing those electrons. So you might be thinking we're going from 0 to +3. That's going up, that's gaining, right? Remember, electrons are negative. So losing a negative is gaining a positive. So we're losing 3 electrons here from 0 to +3. The other thing that's changing in our equation is the tin. The oxidation states of tin. So we go from +4 to +2. So in that case, we're gaining 2 electrons for that. So you have to balance those out. So we have a loss of 3 and a gain of 2. We have to make sure that those balance. So we multiply the 3 by 2 and 2 by 3. So we get 6 electrons total. When we do those, we use those multiples as coefficients. So we take that 2 down in front of the iron and the iron chloride down at the end. We take the 3 up in front of the tin chlorides here. Now we have to look at the equation. Before we do this, we have to look at the equation, make sure that everything is balanced. So we have 3 tin on this side, 3 tin on our products. We have 2 iron on our reactants, 2 iron on our products. We have 12 chlorines over on our reactant side. We have 6 and 6 on our product side. That's 12. Everything's balanced. So by inspection, we've balanced it. Next step that we have to do is we have to define what's being oxidized, what's being reduced, what's our oxidizing agent, and what's our reducing agent. So remember, oil rig, oxidizing is losing. So what's losing electrons in this case? Our iron. Reduction is gain, so oil rig, so RIG. What's gaining is our tin. So our oxidizing agent, that is what's causing reduction by being, or causing oxidation by being reduced. So that's our tin is being reduced, so it's causing oxidation. And our reducing agent is going to be iron because it's being oxidized, which is causing reduction. All right, so write these 2 equations down. We're going to do those together in class. Have a good day. We'll see you in class.